theme in that literature. Is it possible to use the areas that don't change much with age to compensate for the areas that do? It's actually kind of a tricky question. I mean, as appealing as the idea is, and it's one of those things that the more optimistic cognitive aging people will sort of throw out in discussion sections, but you actually try to think about it in more depth, and when people actually try to do research on the question, it's actually not that easy in most cases to figure out a way where, you know, if something is not automatic for you, how are you going to accomplish something that should require effortful processing by automatic processing? Is it possible to do things with implicit learning on purpose? Can you really use semantic knowledge to make up your semantic memory store to make up for losses in episodic? It's not obvious that there are ways that you can do that. There are other things, and we'll talk more about these later today, even that you can do to improve older adults' memory if they'll sit still for it. So one thing is just the whole kind of optimism, pessimism sort of issue, and another one like this. Oh yeah, the other thing is that, as it's true just about everything in the biomedical and social sciences, you have to have statistically significant differences to get published. So, I mean, unless you have a really large sample with a lot of statistical power, and you're testing something that everybody else thinks there is an age difference in, and so that you have like really good solid evidence that there's not an age difference. If you don't find age differences, you don't get published. So, and you do stuff to make your study work, you know, and this can go actually in either direction. I mean, sometimes you actually have to, older adults can be, on average, so bad at something that you have to find a way to make it easier so that they can participate in the research at all. Or on the other hand, sometimes you can get like ceiling effects where like everybody is so good on the task. You don't get differences between young and old. And then, especially if you're on the more, you know, I'm going to find age differences, damn it, kind of approach, you crank up the difficulty of the task until you find a statistically significant age difference. People have gone after things like automatic processing, different kinds, semantic memory in exactly that way. You have like years of studies showing almost no difference in semantic memory, but if you make the task hard enough, you can get some.
Yeah, I'm pretty familiar with the literature, and I would agree with you. And there are also other problems, like a lot of the tasks that they use, and I'm sure Castle used this. I mean, he didn't really talk about his methods that much. Is a lot of these tests are on the computer, and older people just aren't as familiar with the computer, so they start at a lower level there. But I also think that there's a problem with, especially going back to the talk today, that that you can frame some things differently. Like at the beginning of the talk, he talked about how, like, he kind of mentioned that older adults were better at, like, just learning, and he talked about them forgetting, like, the source information. And then later it kind of seemed to me that he was, like, working on training older adults or showing that older adults are able to do this, like, focusing on what is important. And it seemed like they were training older adults to kind of do what they do naturally. And I think that people should or could think about maybe that older people are just better at forgetting. You know? Because, I mean...
Look at rumination and see if they ruminate as much.
You know, like, I just think that there are some different ways that we could frame some things. Like, maybe older people are better at forgetting some nonsense and better at picking out what is really important.
Well, again, I mean, if you think, just kind of think a little more depth than some of the comments we had at the colloquium about what adult life experience is like. Is, the older you are, the more stuff you learn, the more stuff you know. And particularly as you move from an educational environment to a work environment, a lot of your focus is, what do I really need to know? for my job, for my life. And then there's all this other stuff that's coming at you all the time. It's like you end up remembering more of than you want to. But it is, a lot of it is kind of like focusing on specific information, and so some greater ability to discard things that you need or are interested in, or for more instrumental reasons need to know, probably is a big part of it. Yeah, just to follow up on the reframing kind of comment, there are some people at UCLA, there's some names I can't remember, who have looked at some of the literature, especially on like long-term memory, episodic memories and stuff, and suggest a model that explains some of the same age differences, but it kind of puts a generally more positive spin on it, in the fact that they look at these connectionist, associationist models of long-term memory, and they take very seriously the fact that as you get older, there's more stuff in your long-term memory. So if you're looking for any one thing, you have to sort through more stuff. And also you have, some of those things are very strongly interconnected, which is a real plus when that's what you're looking for. And if you're close to this, and you've got a real strong connection going this way, that's a really big help. But if you're close to this and what you need is over here, your strong connection is over here, it's a disadvantage. The same kind of life experience can kind of either help or hinder, depending on this kind of patterns, both associations and just the sheer number of things you've got in mind. So in a sense, it recognizes some of the positive aspects of growth in your learning and memory over adult years, and points out how even that can cause problems depending on what you're testing for. Yeah. So, as a reminder to you, here's what's happening here is that you're learning word lists with younger and older adults, learning word lists across the figures that we'll be looking at. The results in terms of words recalled are done in terms of pre-recall, cued recall, and then recognition memory to see what differences those make. Because they're interested in divided attention and the cost of divided attention, they're also having people do this choice reaction time task where they're looking at 4 boxes and they've got 4 fingers on 4 keys, and you have to hit the key under the box that something appears in the middle of. While you're either encoding the words or retrieving them. And actually, back to the conceptual point they're after here is they were interested both in whether divided attention would differentially affect encoding and retrieval, and also in the question of your ability to control that effect. And so they're trying to separate out this kind of explicit, implicit, effort, non-effort, controlled, non-controlled dimension from the question of automatic processing. So, marching our way around here, you've got, this is younger adults, let's see, without full attention, older adults, full attention, pre-recall. This is the white bars are divided attention and encoding, and then people are told to either focus more, relatively speaking, focus on the memory task, focus on the reaction time task, or split at 50-50. And so you can see, particularly at encoding, it goes down systematically. And go up here.